is partial pressure. Partial pressure is the pressure of a single type of gas in a mixture of gases. It is also known as a force exerted by a gas. The figure shows the example on what partial pressure is. The oxygen exerts a partial pressure. The nitrogen exerts another partial pressure. And the total of the mixture between these two gases are known as total pressure. The table shows the partial pressure of atmospheric gases. Atmospheric gases includes nitrogen, oxygen, water, carbon dioxide, and other gases. The nitrogen has the highest partial pressure in atmospheric, followed by oxygen, water, carbon dioxide, and the others. Partial pressure is extremely important in predicting the movement of gases. A gas will move from an area where its partial pressure is higher to an area where its partial pressure is lower. In addition, the greater the partial pressure difference between the two areas, the more rapid is the movement of gases.
What is Dalton's law? Dalton's law was invented in 1801 by an English chemist known as John Dalton. It is a partial pressure used to determine the individual pressures of each gas in a mixture of gases. The formula is shown as below. The total pressure of a mixture of gases is equal to the sum of the partial pressures of the component gases. Dalton's law also implies that the relative concentration of gases does not change as the pressure and volume of the gas mixture changes. Air that inhaled into the lungs will have the same relative concentration of gases as atmospheric air. The relative concentration of gases determines the rate at which each gas will diffuse across the alveolar membranes. Henry's law was formulated by the British chemist William Henry in 1803. It stated that at a constant temperature, the amount of a given gas dissolved in a given type and volume of a liquid is directly proportional to the partial pressure of that gas. It can be shown that when a gas is in contact with the surface of a liquid, the amount of the gas which will go into solution is directly proportional to the partial pressure. It can be shown by the carbonated soft drinks. Before the bottle or can is opened, the gas above the drink is almost pure carbon dioxide. When the bottle is opened, some of the gas escapes, giving the characteristics hiss, because the pressure above the liquid is now lower. Hence, some of the dissolved carbon dioxide will come out of solution as bubbles.
Partial pressure of oxygen in the alveolar. Oxygen partial pressure in alveolar is lower compared to oxygen partial pressure in the atmosphere. The upper airway of the lung humidifies the air that enters it. Therefore, the oxygen partial pressure is reduced by the partial pressure of water vapor into about 150 mmHg. Other than that, the difference is also caused by the pulmonary capillaries' constant uptake of oxygen and constant diffusion of carbon dioxide into the alveoli from the capillaries. The alveolar oxygen partial pressure can be calculated from blood gas measurements by the alveolar gas equation.
The partial pressure concept can be exemplified by using two important aspects of gas exchange in the lungs, namely ventilation and perfusion. Ventilation is the movement of air into and out of the lungs, whereas perfusion is the flow of blood in the pulmonary capillaries. Ventilation is basically regulated by the diameter of the airways, and on the other hand, perfusion is regulated by the diameter of the blood vessels. Principally, the diameter of the bronchioles is sensitive to the partial pressure of carbon dioxide in the alveoli. A greater partial pressure of carbon dioxide in the alveoli causes the bronchioles to increase their diameter, as will a decreased level of oxygen in the blood supply. It also allows carbon dioxide to be exhaled from the body at a greater rate. A greater partial pressure of oxygen in the alveoli causes the pulmonary arterioles to dilate, thus increasing the blood flow. Ventilation must be sufficient to create a high partial pressure of oxygen in the alveoli. If ventilation is insufficient and the partial pressure of oxygen drops in the alveolar hair, the capillary is constricted and blood flow is redirected to alveoli with sufficient ventilation.